In example 2 of lesson 24, we're trying to evaluate this product. This is two rational expressions, each of them with a single variable x, and we're asked to just multiply these two things. So as we learned earlier in this lesson, I can multiply the tops and I can multiply the bottoms in order to get this product. Now, normally, if I'm going to multiply an expression like this, 3x minus 6, times something like 5x plus 15, I would end up with some quadratic expression. But that's kind of going in the wrong direction if we hope to cancel anything out or divide out any common factors on the top and the bottom. So rather than going through with that multiplication and then having to go backwards and factor everything, I'm going to try to do some factoring first. So let me begin by noticing each of these four expressions on the tops and the bottoms of these rational expressions. Each of them have a common factor. This one, of course, I can factor a 3 out, and that becomes 3 times x minus 2. And on the bottom, I can factor a 2 out, and this becomes 2 times x plus 3. Let me go ahead and do the same thing over here. 5x plus 15, factor out the 5. 4x plus 8, factor out the 4. Now you can see we've got quite a lot of common factors here that we'll be able to cancel. You can cancel either before or after you multiply. So the first thing I might do is just notice we have an x plus 3 and an x plus 3 on the top and the bottom. And so I will divide those out. X plus 3 divided by x plus 3 is 1. So in essence, I can remove those two factors, and all I end up doing is multiplying this entire product by 1. And it looks like maybe those are the only common factors. So let me rewrite what I'm left with. There's the product of the numerators. And then on the bottom, I get 2 times 4 times x plus 2. And of course, we can simplify this a little bit better by multiplying those constants. 5 times 3 this is 15 times x minus 2. And on the bottom, we get 8 times x plus 2. And that is the product of these two original rational expressions in its simplified form. Might want to also go back and notice that x cannot equal negative 2 because that would cause this expression to be undefined, because if x is equal to negative 2, we would be dividing by 0, which is undefined. But we also got to think about what happens over here. X can also not equal negative 3, because in the original product, before we canceled anything, if x were negative 3, then we would also be dividing by 0. So we have to account for those values of x that would cause the expression to be undefined.